Okay, we are talking today about natural logs. So we have done exponential equations, solving for x, logarithmic equations, solve for x. Today we're going to do natural log, right? So here is your notes, 6.6. I've got 9, 13, 10, and 14 that I'm doing today with you. So first I'm going to start with 13 and 14 because these are the easiest ones. Okay, notice how on each side I've got natural log base e. I don't write the base e, but base e is implied. Natural log base e. Okay. Then, since they both have the same on each side, I set the numbers, the natural log that we're trying to find, equal to each other. So go ahead and do that. And that's an easy two-step equation. Go ahead and solve it. I hope you found it as easy as I did. X equals 3. 14 is done the exact same way. Go ahead and do 14. Set them equal to each other. The 2x plus 3 and the 5x minus 6. Someone on Zoom, tell me what you got.
X equals 3.
Yeah. Just a coincidence that it was the same. But it was x equals 3. I'm going to now jump, because notice on number 9 and 10, I don't have natural log written. I have the exponential form, e. My job is still the same. This is an equation. This has an equal sign. I'm trying to solve for x. So I'm trying to get x alone. Now this is the time, and you were talking about this earlier, Hannah. Now I can subtract 9 from both sides and divide by 4. Divide by -4. Okay. Now, I'm going to show you 2 ways to solve this because this is kind of easy, but they're not always this easy. E to the something power equals 1. What exponent always gives me an answer of 1? Like
0.
0. So x is going to equal 0. But let me show you, this is easy. Remember these rules over here? Natural log of 1 equals 0. Natural log of e equals 1. Because it's, base e. I don't write base e, but it's implied. E to the 0 power equals 1. E to the first power equals e. Yeah? I drew my little arrows. Right? Everybody, yes. Okay, I remember this. Yes. Let me show you the mathematical way with like the true steps. If I don't know what to do, I am going to natural log both sides. So you're gonna take the natural log of both sides, which means I get this problem right here. ln of e to the x equals ln of 1. And then it's like, well, I know that this is base e. Remember when they have the same base in the number? You just write the exponent. This is one of my log rules, properties to know on that worksheet. It has like 20 different, the list. But ln of 1, oh, is 0. So I get the same answer, but we are going to take the natural log on this one too. The answer is 0. Next, still, I'm trying to isolate the x, which means get rid of the 1/2. Take the natural log of both sides, BS, both sides. And here's what I got. Natural log of e to the negative 2x power equals the natural log of 12. Can you guys get your calculators out, please? Because we need to make sure that we can do all these natural log things. This I can calculate. This has a value in math. And since it has a value, I'm going to find what that value is. So on your calculator, there's the ln button, right? And above it is an e to the x. This is what we're talking about with the inverses, natural log, and this is exponential. In your calculator, you might have to put the 12 first and then the ln button, or maybe you can put the ln button and then 12 and enter. You have to try both ways. Whichever way you try, since they both have an ln, I can say, and you know this is base e, right? I can say negative 2x equals, and I got ln of 12, I calculated it. I got negative, wait, 2.48. Let's just do 2 decimal places. I know I could make this 2.49. I could also make this 2.5. The more decimals you have in your calculator screen, the more precise your answer is. So if you can leave, like look at my calculator. I'm able to leave all these digits in, and that's really good because then I'm going to be able to divide both sides by negative 2.
Why couldn't it be like negative 2x equals 12?
Because natural log, this has an actual value. This is a number in the world. This has a value of something. And its value is not 12. Its value is 2.48. And since we're working with natural logs, I actually need to calculate what this value is. We're going to do it again on the next page too. X negative 1.2, approximately like negative 1.24 or 25, whatever. They're all close enough. I would take both answers. And notice, Rena, this didn't say ln of e negative 2x equals ln of whatever e to the 12th. It didn't say that. This you would set equal to each other, but that's not what it says. Okay? So I don't want you to, this is not what it says.
Okay, yeah.
I need to go to the next example, which is 18. Can you flip the page or turn the page or get to 18, however that is for you? Look, there's not a natural log on both sides. I can divide by 4. And I will. This is natural log. I need to change, because I can't solve this as it is. There's nothing I can do. To exponential, that's my e form, remember? E raised to the power of ln 2x, and remember it's base e. I just don't write base e because nobody writes base e. Equals e to the 5/4. Okay. Using my log, my natural log and log rules, I know that an e ln e, that's all the same. So I'm good to put 2x. But right now, I don't have e ln 5/4. I have e to the 5/4. You have to calculate this value. Okay, because again, this did not say, this is what it did not say. It did not say e to the ln of 2x equals e to the ln of 5/4. It did not say that. That's what makes you have to calculate the actual value of this number. You have a calculator. E is the button, is the value above ln. It's the inverse, so it's above ln. You have to either use like the second or shift. I don't know what your calculator says, but you have to do the second button and then press ln, right? And then the exponent that you're doing is 5 divided by 4. Some of your calculators, you might have to do 5 divided by 4, second function ln. You might have to do this, maybe. Everybody's calculators are different. Or maybe you just do second ln. You might have to put a parentheses, 5 divided by 4, maybe no parentheses. I mean, the point is that you should get as your decimal 3.49. Do whatever you need to do to get 3.49. E to the 5/4 is 3.49. Okay. Now, there's no e, there's no natural log. I just divide by 2, both sides. So, divide by 2. What is it? 1.7 approximately. 1 decimal, it's like 2 decimals after, 2 numbers after the decimal is best because it's more precise. A teacher's never going to want like 6 numbers after the decimal. That's just ridiculous. But the 1 number after the decimal, like, could you round? Is it precise enough? There's those kind of questions. I'm going to stop the recording.